Good morning. Welcome to this edition of Geometry, Cosmology, Spirituality. It's 2:30 a.m. in my time zone, and the new moon is happening in about 25 minutes' time. In this session, I'm going to look at some of the measurements of the Great Pyramid. Now, this is a photo that I took while I was traveling back in the mid-1990s. It was, as you can see, when I was visiting the Great Pyramid, which is the pyramid to the right in this image. Now, I've taken a great interest in the dimensions of the Great Pyramid because of something that I've found in my research concerning the cathedral here in the city of Wells. So I'm going to talk a bit about that in this session. Now here, as you can see, is an image of the Great Pyramid, and marked within it is a particular triangle, which within the Great Pyramid, as you can see, the height of the triangle is 280. Now that's 280 Egyptian royal cubits. And then the baseline of the square base is 440 Egyptian royal cubits. Now, if you were to divide these two amounts or these two numbers of cubits, if you divide them both by 40, then you come up with these two numbers. You come up with the numbers 7 for the height and 11 for that square baseline, or for the edge of the square baseline. Now, these numbers are also found in this diagram here on the right, which is, well, something that I call the Earth-Moon diagram, which is somehow envisioned by John Michell in about 1969, 1970, sometime around then. He published it in a book that he brought out in 1972 called City of Revelation. Now, this diagram, as you can see, it has the pyramid triangle within it with its base of 11 and its height of 7. Now, this, as you may be aware, this diagram, this circle here is the size of the Earth in relation to this one, which is the size of the moon. Now, the moon circle has a diameter of 3, whereas the Earth circle has a diameter of 11. Now let's take a look at those cubit numbers again of the Great Pyramid. So 280 cubits in the height. If you were to multiply that number by 18, you get 5,040. Now 5,040 is the number of miles which is in that height of 7 within this diagram. So if we think of this as being Earth, then the diameter of the Earth plus the diameter of the moon is equal to 5,040 miles. If we take the number 440 and we multiply that by 18, then we get 7,920, which is the mean diameter of Earth in miles. So that's this distance here. Now, where this comes into Gothic cathedral design, the example that I've shown in my book, The Cosmos in Stone, is in this place here. So as you can see, there's a pyramid triangle going from the center of the crossing to the threshold of the Lady Chapel, and then going up to the center of the chapter house on the north side of the cathedral. If you apply John Michell's diagram of the Earth and the Moon to this architectural layout, then you find that the moon square going around that circle with the diameter of 3 fits very neatly into the chapter house. There are lots of other things in that area of the cathedral that have, I suppose, lunar numerics, so such as the number of steps in the staircase and this skew in the architecture here in the vestibule. I've talked about this in various of my talks, cosmic pyramid geometry in Gothic cathedral design. If you see the second of those three talks, which is on my YouTube channel, I go into lots of detail. So I won't go into detail with that this time because that's already on another film. But this shows how the diagram that John Michell somehow envisioned in the early 1970s does seem to have been known about by the Gothic cathedral designers. Now, the other thing about this pyramid triangle that's used in the design of Wells Cathedral is that it has a very simple fractional relationship with the size of the Great Pyramid. So if we think of this triangle before us here as being the cross section of the Great Pyramid, if we divide that baseline by 5, then this one here is effectively the triangle that's used in that master diagram at Wells Cathedral. So if we take the baseline, which is 440 cubits, and we divide it by 5, we get 88, and that's essentially what you have in each 1/5 of that baseline. So 88 times 5 gives the 440 cubits of the Great Pyramid. Now, if we take that height of 280 cubits and we divide that by 5, we get 56 cubits. And so that's the height of the pyramid triangle used in the Wells design. So here we have that pyramid triangle that's used in the design of the cathedral here in the city of Wales, a baseline of 88 and a height of 56. Now I'm just going to gradually work my way to showing how this knowledge of the size of the Earth and the Moon does seem to be present in the design of the cathedral. And I just need to go via another slight digression before I get to the final point. And that's the measurement units that are used in the design at Wells. Now look upon these three sticks here as measurement rods, and they're all different foot units. They have musical relationships within their differences. This one here is the English foot, and then you have one that's a bit bigger, one that's a bit smaller. Now this is all described in detail in my book, but just briefly for now, I'll just say how they're divided up by this single micro unit, and that really is the micro unit, the atomic unit, you could say, of the whole cathedral. So the larger foot is made up of 56 of these micro units. The one that's the English foot is made up of 52.5 micro units. And the smaller rod is 50 micro units. Now I need to get to the cubit because that's the other measurement units that's used. And that's the one that I'm talking about in relation to the pyramid triangle. So the cubit measurement rod is made up of 90 micro units. Now, I'll go into detail with this another time with the musical relationships of these numbers. But for now, let's just look at the cubit that's made up of 90 micro units. Now, this cubit is the same as what's in modern description called the Egyptian royal cubit. And what we can now say about this is that if we have 88 cubits along the baseline and 56 cubits in height, if we were to multiply that 88, the number of cubits, by the micro units, then we can see how many micro units there are in the measurement of the Wells pyramid triangle baseline. So there we have it, 88 cubits multiplied by 90 micro units. It gives 7,920 micro units. So that's the amount of micro units in the baseline of the pyramid triangle used in the design of the cathedral here at Wells. Now, if we do the same thing with 56 cubits multiplied by 90 micro units gives 5,040. Now, these two numbers are the numbers, well, the mileage numbers of John Michell's diagram. So this distance here is 5,040 miles, and this one here is 7,920 miles. So what this demonstrates is that the designer of the cathedral here in the city of Wales was aware of the mileage measurements of the Earth and the Moon, as well as being aware of the dimensions of the Great Pyramid in the sense of there being a fractional relationship with that as well. Right, so I shall de-share my screen and say hello. Well, good morning and well done for making it if you're in my time zone. Right, I shall now share my screen and I'll show you the diagram that we're going to draw. It's a diagram to do with the size of the Earth and the Moon, but it's a different one. It's one that I haven't really shown before um, in my book or anything of that sort. It actually involves fivefold symmetry. Now, it's one that Robin Heath shows in one of his books. And now I said in the diagram how the size of the Earth is, or the diameter of the Earth is 11, and that the diameter of the Moon is 3. And that's what we have here. So within this pentagon, we have this circle, which has a diameter of 11, if this circle has a diameter of 3. Now you can see the size of these two circles is coming from the pentagon. So usually, like in John Michel's diagram, it's a pyramid triangle which is used. But here, by putting in these circles, whose diameters are the same as the edge of the pentagon, what we get is the size of the Earth to the size of the Moon in this fivefold diagram. So that's what we shall now work our way through. Now you'll need to have a piece of A3 paper. Right, now I'll just fix my camera so it's in the right position. Okay, right, let's get started. Now, one thing I didn't actually show, I might as well show again. Now you can see how this, if we count in half inches, because the diameter of the moon circle here is 1.5 inches, then you can say that 1, 2, 3 half inches. Whereas a moon square is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 half inches. So you have the 3 and the 11. But these circles also have a rational measure 2. Now they are 8 half inches. So 1, 2, 3, 4, 5, 6, 7, 8. So again, we're going to do a mixture of compasses geometry and rational units of measure, all in the same diagram. Right, find the center of the page between top and bottom. Right, to get all of those simple rational numbers used, we need to have this rather obscure measurement in our radius. So I'll describe that just very gradually. Now, 3 inches, 1, 2, 3, and then with those sixteenths, those little increments of which there are 16 an inch, I'm going to count 1, 2, 3, 4, 5, 6.5. So it's a really very specific measure, which then makes all of those inch numbers come up in the diagram that I just showed you. So as I say, 3 inches, and then 1, 2, 3, 4, 5, 6 sixteenths, and then add another 1/2 on, so 6.5/16. Right, so now you've got your circle. We need to put in a horizontal line. We're going to do the division of the circle into 10. Obviously 5 is the predominant shape, but we do need the 10 to help us to with the construction. Now, keeping that same radial measurement that we have for the circle, place the point of the compasses onto the eastern point of the circle and mark off like so. Now we'll do the same thing from the western point. Now, the one thing that we're going to need to do, which changes the compasses, is at this point here. So I'm going to reduce the radial measurement on my compasses a little bit so that I can get across directly above the circle, like so. Then into this point here. And then an equivalent move down here. Now, in terms of how much you reduce the measurement on your compasses, it's no definite amount. It's a sort of indeterminate amount. As long as you can have your cross somewhere here above the circle and this cross somewhere below the circle, it doesn't really matter how much you reduce your radial measurement by, as long as you can basically make your cross fit on the page. Right, so as you can see, I'm now lining up these 2 points so that I can draw another vertical line between those two. And now I'm going to do the equivalent thing on this side. Now, what these lines should give us is the midpoint between center and circumference, and likewise on this side as well. So I'm now going to reduce the radial measurement on my compasses so that I can hopefully draw a circle which will go through both center and circumference, like so. And then in goes the other one. Right, I'm now going to draw a V shape that goes from this point here through the center of that circle and one through the center of that circle. We're actually going to have to do quite a long stretch with this compasses measure. Describe that when we come to it. Having done that, I'm going to also do the upside down V shape as well. Right, so to get this tenfold division, we need to take this measure, and of course it should be the same as that on there. Now what works down there should also hopefully work in the same way up here. And this is 1/5 of the circle, or from there to there is 1/10. Right, as you can see, I've got this measurement, like the actual line that forms the V. I've taken the length of that line as my radial measurement, and I'm going to do this and this. They just need to cross the circumference of the main circle. I'm just in the habit of extending them to create a shape. Now, here are the 10 points, tenfold division of the circle, which I'm marking here. So mark these, and what we're going to do is put pinprick holes through the paper. I forgot to mention that you're going to need to have paper which is blank on both sides. So if you already have something on the other side of your paper, you can place this paper on another piece of paper and put pinprick holes through both bits of paper. Right, so I'm now going to put these 10 pinprick holes through so that they become visible on the other side of the paper. Right, it's the time of the new moon now, so perhaps it's a good time to contemplate new beginnings. Right, so having put pinprick holes through those 10 points, now turning my paper over. Now you can probably see your pinprick holes, but I doubt you can see mine. So I'm going to mark mine, but don't feel the need to do that on yours because you can probably see your pinprick holes. But I'll mark mine just so you can see how I interact with them, with what we're now about to do. Right, so first off, I'm going to draw a pentagon using 5 of the points. So obviously I'm missing every other one. Now here is this container, this pentagonal container, which is going to define the size of the Earth and the Moon. So begin by putting that in. Oh yes, one thing I forgot to say, you may already have this, but we also need the hole that's at the center of the circle as well. You may already have that. You can perhaps put that in just to be sure that's there, because we're going to be using that. Right, the next thing we need to do, these 5 points here, which we haven't used in the pentagon, I'm going to line each one of those points up with the center hole that I just produced there. And I'm only going to draw just a little bit of line like that. That's so that we can get the midpoint of each one of these edges, because that's obviously how we're going to draw the circle, like so. So we need to do that. And if I were you, I would go, as I say, line up with the middle of the pentagon, and then you can draw the line like so. Now you obviously can use the size of the pentagon to just draw the Earth circle, which is going to tangent the 5 edges of the pentagon. But what I'm actually doing is taking what should be the measure, I'm taking it off the ruler. So hopefully I've drawn accurately. Now the measure I took off my ruler to do that is 2 3/4 inches. So that's basically half of 5.5 inches, which is the measurement there, which, as I said, it's basically altogether the diameter of the circle is 11 half inches. 1 2 3 4 5 6 7 8 9 10 11, which is, in terms of the ruler, 5.5 inches. So I took half of that measure, 2 3/4 inches. That was the radial measurement that I used. Now these edges of the pentagon, they should measure 4 inches. So if you take half of that 4 inch measurement from the ruler, now again, you can do this just by eye. You don't really need to use the ruler to do it. This thing of, I suppose, mixing compasses geometry with rational units is very much what you find in architectural design, because obviously you can't use the irrational measures. So the golden ratio is 1.618033, and you can't have 1.618033 bricks. So you use rational approximations like Fibonacci numbers. So what we're doing here is quite an interesting mix of these two different types of geometry. So you see how, it's possible to do all of it just by eye, but you can also, in this particular instance, with this diagram, you can also just take your measurements off the ruler as well. And that's because we started off with that rather obscure measure on the ruler, which then happened to make all of these measurements rationally coherent. So these 5 circles that we've put in, they give us the possibility of putting in the moon circle here, which will tangent those circles, and go with the Earth circle with its diameter of 11 units. And then this circle will have a diameter of 3 units. Now, if you want to take the measure off the ruler, what you need is 3/4 of an inch. Now, hopefully, if my drawing is accurate, which it looks like it is, phew, that's a relief. And so you have the size of the Earth to the size of the moon, but coming from fivefold symmetry. It's a very interesting diagram. Again, I think I said it's by Robin Heath. He's the one who first shows it in one of his books. Now, if you're not aware of the work that I've done about John Michel's diagram and the size of the Earth and the Moon, look at my talks on my YouTube channel called Cosmic Pyramid Geometry in Gothic Cathedral Design. I go into detail about John Michel's diagram in the second one of those talks, but it's worth watching the other two as well, particularly the first one that will then lead you on to the second one. Also, the second edition of these moon sessions. So number 2, which I did all the way back in, I think, October last year, I also talk about John Michel's diagram in that session as well. So that session, the talks and this all sort of go together as one set of studies of those correlations of Great Pyramid, size of the Earth and the Moon, and the design of the cathedral in Wells. Right, hello again. I'm going to share my screen one more time. Right, here is an in-person class that I'm teaching here in the city of Wales about symbolism of the pentagram. So we'll be doing the fivefold division of the circle quite a lot in that course. Do come to that if you're free. And I'm going to do one of my online courses. This is the first online course um, that I'm doing beyond these moon sessions that I've been doing for the past year. Now, this one is looking at John Michel's mandalas. You've heard me mention John Michel on various occasions during this session. And in this course, this online course, which is beginning at the beginning of October, we should be looking at some of the mandalas from his book, How the World is Made According to Sacred Geometry, such as the one in the image here. So wherever you are in the world, you're welcome to join me online for that one. Do come along to that. Now, the next session is on the full moon. And again, it's another late one for those who are in my time zone. This time it'll be 3:30 in the morning. It's the penultimate one that I'll be doing. The final one that I'll do will be the new moon in early October, which will be at a much more reasonable time if you're in my time zone. That'll be about 7 o'clock in the evening, I think. So this next one, all of them obviously go onto YouTube as always. So do come and join me for that one if you're free. If you're in the United States or Asia, then it should be a lot easier to join me at that time. But you're welcome to join me wherever you are. So thanks for coming to this one, and I look forward to seeing you again at a future session. I shall see you next time. Thanks for coming.